And can you the relation between resistance and length is directly proportional, and the relation between area of cross section is inversely proportional. Clear, Zainab?
Sir, in the homework you have given a question, right? The question fourth one. To find, you have given two values for current, sir, and you have told to find the same current flowing through the same wire, so it's kind of confusing.
Okay, share with that question to me, dear. Let's find out. Okay. Sorry for that. I just forgot to ask for you. Just a second. Let me open the PDF, homework PDF. Give me a moment, dear.
Yes, sir.
Just a second, Zainab. Sorry for the interruption, dear. Sorry for that. What was the question here? Like, the topic was potential difference in electric current, right?
Yes, sir. The question was a potential difference of 10 volt to 6
Okay.
button.
Let me check that first. Yes. Question number 4.
Yes, sir.
Calculate the work done in moving a charge of 4 coulombs from a point to 220 volts to another point to 30 volts.
Yes, sir.
First, A part is state the relation between potential difference work done and charge moved. Second part is calculate the work done in moving a charge of 4 coulombs from a point at 220 volts to 230 volts. Right? That was the question here.
No, sir. It's a different one.
It's a different one. Let me
Yes.
check again. Which question are given? Let me check first. Actually, it's been some weeks, so a little bit. I have to search for it. Okay, Zainab, you can tell me. Sorry, dictate the question to me, dear. Okay. Let me write that question right in front of you so that like you don't have enough time to search for that. Give me the question dictation. Zainab, can you please dictate the question?
Of 10 volt.
A potential difference of 10 volt
is needed to make a current of 0.02 ampere.
It needed to make a current of 0.5 ampere.
0.02 ampere.
Okay, 0.02 ampere. Okay, then
flow through a wire.
Flow through a wire. Okay, next.
What potential difference is needed to make a current?
What potential is needed? To make a current of
250 milliampere flow through the same wire.
250 milliampere, na?
Yes.
Through the wire. So this is a simple question, Zainab. Let me explain that to you. This is basically nothing but this is the application of Ohm's law. Okay, so basically V1 is 0.0, not 0.0, it's 10 volt. Let's suppose that we have like let's first consider the example. Let's first consider the situation in which the current is flowing 0.2 ampere. So the current is flowing 0.02 ampere. having a potential difference across the wire is 10 volt. So it would be V1, suppose that. Clear? 10 volt. And I1, the current flows through the 10 volt ohm is 10 volt is 0.2 ampere. Okay. So now tell me, Zainab, if now tell me the wire, basically the current, the second current, 250 milliampere is current is also flowing through the same wire, or is the wire is like, or you are changing the wire?
Same wire.
Same wire, na? So the resistance will be same because we are not changing anything. We are remain like the length is same for the resistor, the area of cross section for the resistor. So no, at least yes or no? Yes, na?
Yes, sir.
So V equals to IR. So R will be V by I. Clear? So what is the value of V is 10 and it is 0.02. So two decimals are there. So 10 into 100. If I remove these two decimals and two fives are 10. So 500 ohm of resistor is required at in this situation. Clear, Zainab? Okay.
Yes.
So your wire is not changing. Only the value of current is changing and the potential will also change because potential depends on the current. We is directly proportional to I. Clear? Yes or no, Zainab?
Yes.
Because this is a
Yes.
constant value, na? So it will not change. The value of current and potential difference will adjust according so that the resistance would be same for like for the same wire. Clear? Now I'm applying. Now we need to find the value of V2, and I2 is given as 250 milliampere. So I can write 250 to 10 to the power minus 3 ampere. Milli is the 10 to the power minus 3 quantity?
Yes, sir.
Yes or no, Zainab? Okay. Next thing. So again applying the Ohm's law. Resistance will always be same because resistance will not change of a wire because we are not changing anything. So
Sir,
V
why
will
can't
be
we take only 250 ampere?
250 ampere. Why can't we take?
Yes, sir.
Zainab, if it's written 250 milliampere, so how can we take 250 ampere?
So how did 10 to the power minus 3 came?
When milli word is used, so milli is 1 by 1000. When we say that 1 milli word, so it's nothing but it's 1 by 1000. Milli word. Have you heard 1000 milliliter
Yes,
is
sir.
equals to 1 liter? So 1 ml will be equals to 1 by 1000 liter. Yes or no, Zainab?
Yes, sir.
Same goes happen with, so 1000, not 1000. So same goes with the current as well. Yes or no? 1000 milliampere is equals to 1 ampere. If I want 1 milliampere, so it would be 1 by 1000 ampere. Yes or no, Zainab? Because due to exponent law, so this is 1 milliampere will be equals to 10 to 1 by 10 to the power 3. Three values of 3 are not. 3 zeros are present or not. So I can write in the exponent form.
Yes, sir, we can.
Zainab, 10 to the power into 1 into 10 to the power 1. If the bases are same, the powers get added. So it will equals to 10 to the power 2. Now here, 10 into 10 into 10. 1000 is nothing but 10 into 10 into 10. 1, 1, 1. Power. How many powers are there? If you add up, 3. That's how 3 comes. And now here, if the power is in denominator, and if we take that power into numerator, so basically this will become minus 3. This is the law of exponent.
Yes, sir, got it.
Clear?
Yes, sir.
That's how we got the value of milliampere in 10 to the power minus 3 terms. Clear, Zainab?
Yes, sir.
Very good. Just give me a moment. Okay, let me raise this first. So I is 250 into 10 to the power minus 3 into 500 because R is same. We are not changing we are not changing the wire. Yes or no? And I'm audible here. At least say answer.
Yes,
So potential will be, sorry, it's V2. V2 is 250 into 5 is 125, 10 and 3 zeros. So 3 zeros will come here into 10 to the power minus 3. So Zainab, see that if I 125 into 10 to the power 3 into 10 to the power minus 3, if I multiply them, bases are same, power will get added. 3 minus 3 is what?
0.
0. And then if any base has the power 0, what it basically?
1.
1. So the value is 125 volt. That's your answer. Clear, Zainab?
Yes, sir.
You can see the wire is same, so it will not change the value. Basically, the resistance value will not change. I've told you that the resistance will be constant. Why? Because the resistance is a constant value when we have proved that when we have basically taken the Ohm's law. Clear? Clear, Zainab?
Yes.
Any doubt?
No, sir.
Okay. Shall we move forward?
Yes, sir.
Okay, that's great. So we have done the factors affecting the resistance. Clear? Yes or no,
sir.
Zainab? Okay. So now, Zainab, now we have seen that. Just a second. Let's come to the point. Resistivity. Okay, Zainab. So now, Zainab, see that thing. Have you seen cricket match?
Yes, sir.
Okay, so Zainab, whenever a new batsman comes into the ground, what is the score of that batsman?
0.
0. Okay. Okay, so one more example. Let's take one more example. Okay, so suppose that a person joins a new job. So it will have a starting salary,
Yes, sir.
default salary. It will be like that. Like somebody has you can say offered a job to that person, and he said, okay, yes. So there will be some value of the salary, default salary value. Yeah. So basically, resistivity is, we can say that, suppose that if I'm taking a copper wire I'm taking, just a second. Suppose that if I'm taking a copper wire, so this is a copper wire, and suppose that the value is 1 meter, and this area of cross section is 1 meter square. Clear, Zainab? Yes. So basically, Zainab, this copper wire will offer me some resistance because it's a conductor, so it will offer some resistance to me. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Yeah. So now, Zainab, tell me, this copper wire, this value 1 meter length and 1 meter square cross section area will have some definite resistance.
Yes, sir.
So basically, the default resistance, you can say that I'm saying the word default because for that value, basically every material has a default resistance. It means that if I take the value, if I take 1 meter length of that wire, of that material, and 1 meter square of the area, so basically the resistance that will offer to me is called as specific resistance. Specific resistance, and that specific resistance is called as resistivity. Zainab,
So both are same, right?
Yes. Both are same. Specific resistance, I'm telling you right here so that you can relate with that to resistance term. That's why I've used specific first, and then I've told you is resistivity. Clear, Zainab?
Yes, sir.
So basically, the specific resistance of material is called as resistivity. Zainab, yes or no? Clear?
Yes.
So Zainab, so basically just a second. So every material will have a definite resistance?
Yes, sir.
Yes or no?
Yes.
Yeah. So that specific resistance is called as resistivity. Clear, Zainab?
Yes, sir.
Yeah. So that's why resistivity. Okay, so basically, if you need to define the resistivity term, you will say that when we take a wire of 1 meter length and 1 meter of cross section area, it will offer me some resistance, yes or no?
Yes.
And that resistance, the specific value of the resistance is called as the resistivity. Clear, Zainab?
Yes, sir.
Yeah. Just give me a moment. Let me snap the value of basically you don't need to memorize the values of resistivities of all the materials, like it's not necessary. Okay, so but you have to only basically Zainab, and resistivity is basically is a very important factor to basically you can say which conductor should we choose for our need. So basically, Zainab, we have two common metals, you can say two common metals which we use in the normal electric household wiring. First one is copper, second one is aluminum. Clear?
Okay, sir.
Okay, let's write down the basically the definition of resistivity. When we take 1 meter of length, when we take 1 meter of length of wire, and just a second, take the proper definition like this. The resistivity. So, first of all, you cannot say the model carbon like this. Why? Because the carbon is not in the chain. So, you can either select it like this substance, like this 1, 2, 3, 4, or like this. But you have to select it like this because you are getting 4 number of carbon 1, 2, 3, 4, equals to the. And these two carbon will be considered as bonds. And the number you give them in such a way that is also two carbon resistance of a rod of substance which is Zainab, dear, don't miss the class after this, okay? Because like you told me that you will be having pre-boards, and if you miss the class, so it's very difficult to complete the syllabus on a time, dear. Okay?
Yes, sir.
Yeah, in cross section. Resistivity in just simple terms, if you take basically we define everything in in unit, like when we take the quantity as 1, whatever is the quantity, we define everything with respect to 1. Yes or no, Zainab? So basically, if somebody asks you that what is resistivity, so you will say that the resistivity of substance is nothing but it's the resistance of a rod of that material when we take 1 meter long of that material and 1 meter square in cross section. The resistance that will offer this value of the dimension. Basically, this is a kind of dimension, na? It's a volumetric dimension because square area and length is covered.
Yes, sir.
Yes, na? So basically, just a second. Yeah. So basically, that is that volumetric dimension. That volumetric dimension will offer you some resistance. That specific resistance is called the resistivity. Simple, 1 meter length wire, 1 meter square cross section area. This dimension, whatever this dimension will give you the resistance, is called as the resistivity of that substance. Because we take the things in the numerical, in the unit values. Clear, Zainab?
Yes, sir.
Yeah, very good. So now, Zainab, tell me, if I have the value resistance is directly proportional to L and inversely proportional to A, I can write this in manner, yes or no? Just a second. Let me write this first, A and L here. Resistance is directly proportional to L and resistance is inversely proportional to A. Yes or no, Zainab? Yes, na?
Yes,
Zainab,
sir.
these are the factors affecting the resistance?
Yes, sir.
Okay. So basically, Zainab, if I merge these values in an equation, so it will be L by A. Clear, Zainab? Because it's nothing but it's saying that resistance is also equals to AL and resistance is directly inversely proportional to A. Sorry. So if we merge this, this will become R is directly proportional to L by A. Clear, Zainab? And so if I remove this proportional sign, so one constant is introduced which is called as the resistivity of that substance. Clear, Zainab? So Zainab, tell me, if you have 2 bananas, if you have just suppose that 1 banana is equals to 4 rupees, okay? Zainab?
Yes, sir.
Interact with me, because this is a topic in which you will definitely get confused. Because when I was in 10th class, I will also get a little bit confused. Why we use the resistivity if we have the resistance? That's why I'm telling you. So Zainab, if you have one banana which is of 4 rupees, obviously yes. So Zainab, if you want the value of 4 bananas, what you will do, dear?
Check the value of one banana.
Yes, Zainab.
I will check the value of one banana.
No. If you have if you have one banana value, if you need the value of 4 bananas, what you will do? Tell me.
Price of one banana into 4.
Price of one banana into 4, which is 16.
Yes, sir.
Okay, comes into this picture. Just relate these things. Zainab, I need to calculate the resistance. Okay, I have the resistance of 1 meter dimension and 1 meter square cross section area. I need, what you will do? If you need to calculate a specific value, specific resistance, like I have taken another dimensions. So what you will do? You will multiply this with the unit value, because you have one value banana. Suppose that this is one banana and you have multiplied with the 4 bananas, because you need the total value of resistance. Here, if you need, basically this resistance is the total resistance of that wire.
Yes, sir.
If I'm changing these dimensions, because it's already these resistivity is the resistance of 1 meter square, 1 meter square and 1 meter length wire.
Yes, sir.
Yes or no?
Yes.
So that's now you are able to relate this. To calculate the total resistance, you are multiplying this resistance to the dimension of the like you can say different dimensions. Suppose
Yes,
that I have this resistivity is equals to 4 ohm meter. Suppose that I'm just saying it's not possible. 4 ohm meter is a very high number. So you are saying that 4 ohm meter is the resistivity of substance, and you need to calculate the resistance of a wire of 4 meter. L is 4 meter. A is 2 meter square. So what you will do? You need the total resistance. You will do that 4 into 4 divided by 2. So basically this 2. So it's 2 4s are 8. 8. It would be 8. Yeah, 8. So 8 ohm will be your value. So this is the total value of that wire that you have taken. Clear,
yes,
Zainab? Now you got it? That's why I've taken the 1 banana and 4 banana example, because it's a little bit like you will, like when I was in, seriously I'm saying that when I was in 10th, I will always think that why do we need the resistivity? What is the need? When I search a little bit and then try to relate these things, then I got that resistivity is the unit you can say the unit resistance of a substance. Like, because we are taking the numerical value equals to 1, everything resistivity mein. So that's why it's called specific resistance. Clear, Zainab?
Yes, sir.
Yeah, very good. So that's how the resistivity and resistance, length, and all these are interconnected. Okay, Zainab?
Yes, sir.
Yeah, very good. So I can write as L by A. Clear?
So that is rho L by A, right?
Yeah. Yes. Rho L by rho is called the, I'm writing here, rho is the resistivity. L is the length of the conductor. And A is the area of cross section. Okay, dear? Area of cross section. Clear, Jana? Yes or no?
Yes,
and just modify this a little bit. If you need the resistivity, so what you will do, resistance into A, this A will go here and divided by L. Clear?
yes, sir.
Very good. Now once let me write down the thing. SI unit of resistivity is ohm meter. Ohm into meter. How? Then listen here. Ohm is the unit of resistance. Yes or
Yes,
no?
sir.
What is the value of SI unit of area?
Meter.
No, area here. Area is always square, na?
Yes, sir.
Area is always square because what we are taking two sides, and every side we are taking in meter. So it will be m square divided by what is the length, what is the value of length, like basically SI unit of length. Zainab, what is the SI unit of length? Meter, na? Zainab, you are muted. Dear, you can
Yes.
unmute yourself for the class. Just I will ignore the background noise. You can unmute because interaction is necessary between us. Okay. So Zainab, if you basically this m will cancel out this one m because it's in square. So what will be left? It's ohm meter. Whenever you just stuck between the what will be the value of the what is the SI unit and what are, just put the value, put the SI units into the formula, you will get the answer. Clear? That's how you can find out the value of the SI unit of the resistivity. Clear, Zainab?
Yes, sir.
Very good. Now, one more thing is that this is a very important thing. Resistivity does not depend on length and area of cross section. Basically, Zainab, what you will do is basically that means that if you have a wire, suppose that if you have a wire, suppose this is a wire, and you have done what? You have just split into two half. Clear? Equal halves. So this is whole wire was L. So this will be what? L by 2. Yes or no, Zainab? This will be also L by 2. Clear or
Yes,
not?
sir.
So Zainab, if somebody says that what will be the resistivity of L by 2 length, it will be same as it is rho. If the rho is the resistivity of total length L, if the rho of resistivity of total length L, then it will be same for L by 2 as well, because it does not depend on the cross section and length of the conductor. Resistivity is the property. So does property change of of anybody? Like if you use basically if you have a like less quantity or more quantity.
No, sir. It
No,
doesn't.
na property. Like if I'm saying like human body, humans are so many. Like they have small and big sizes, but the like blood and red blood cells, white blood cells will be same for everybody. Yes or
Yes.
no? This is the property of a body. Everybody will contain red blood cells, white blood cells, everything. So property will not change, whether it's African, American, Asian, South African, Pakistani, Indian, Bangladeshi. It doesn't change because all are human. Clear? So if you take any material and like one more thing, I'm taking the specific, like I'm taking one material here. If I'm saying that another material is this and you have split it into the two, and 2 rho is the resistivity of that material. So 2 rho will be resistivity of this L by 2 part as well. Clear, Zainab?
Yes, sir.
So resistivity depends only on temperature and nature of material. Depends upon nature of material. Obviously, every material has a different resistivity. Copper has different, aluminum has different, silver has different. So obviously, resistivity will depend on the nature. Yes or no, Zain?
Yes, sir.
And temperature. It depends on temperature as well. Clear? These only resistivity depends on the temperature and the nature of the material. Clear, Zainab?
Yes, sir.
Any doubt?
No, sir.
Okay, dear. Just give me a moment. Yeah. So that's what the resistivity is. Now tell me, Zainab, do you have any doubt between resistance and resistivity? Like, are you able to relate them? What basically resistivity and what is the resistance?
Yes.
Yes, na?
Yes, sir.
Resistivity is the property. It does not change. If I'm saying that I'm taking a 1 meter length copper wire I'm saying that it will be remain as it is. Clear? So basically, I have the chart of this. Basically, I'm pasting that chart in front of you so that you can identify. Basically, we use only so Zainab, basically in household right now, the most common metal that we used is the copper for household wirings. Basically, because the
Nickel also they
resistivity.
use, right?
Yes, Zainab.
Nickel also they use, right?
Zainab, in household wiring, we don't use nickel.
But I've heard
Only
that for constructions, the major under electricity they use it.
Zainab, I'm saying normal household wirings.
Yes, sir.
Have you got this point here? I'm just taking normal household wiring because in every case you will be having you will be needing different material. Obviously, every place has different needs.
Whole they
Yeah.
told that they will use at some points. That's why I
Yeah.
asked.
So basically, Zainab, right now school, like in real life, because book does not contain like every variety of case. It contains a general case. So that's why if we talk about the variety of case, so it depends. Like we use very different materials right now in the construction of houses as well. But the general construction material is nothing but cement, bricks, and one more thing like stones. These are the general things, but we use different materials right now because of the sustainability. It does not cover in the book yet. Yes or no?
Yes, sir.
Yeah, that's what it is. But so we are taking the general cases. So basically, Zainab, these are the two common things that we use in the household wirings. Copper is the most efficient and most you can say and affordable metal that we use in the household wiring, and the resistivity is very low. Why we don't use the silver? Because silver is very expensive. Silver is very expensive, so we don't use the silver. And aluminum offers very high resistivity. Comparison almost, you can see that it's almost double or 1.5 something. The resistivity, because 10 to the power of -8 is the order of say all the materials.
Yes, sir.
So you can see that 1.69 to 2.63, it's almost the jump of 1, and it's a
Yes,
very
sir.
high number in terms of resistivity. Clear? So that's why we use copper, which is the most affordable and the most efficient metal for our household wirings. Whenever you basically, if you find out that sometimes when the electricians comes and takes out the wire, you will see that copperish color, like brownish color wires are there. Not because aluminum is of white color, white or gray color, but the brownish color is there because the copper is used in that wires. Clear, Zainab?
Yes, sir.
So basically, these two values are these two components, the materials are used in the household lives. Clear?
Yes, sir.
Very good. So basically, that's what the resistivity is. And one more thing is that, Zainab, we basically use alloys because we need the high resistance. Okay, we use alloys because of the high resistivities. Because you have seen that iron, electric iron, toaster, and you have seen heater, like circular and coils are there. Electric heater
Yes,
in
sir.
the for the winters. So that also use the alloys, nichrome wires. Nichrome wires
Yes.
is commonly used in the electrical appliances because the resistivity of the nichrome is very high. See that 110 into 10 to the power -8. It's a very high resistivity. That's why you have seen that it glows up orange color.
Yes, sir.
Yes, now. So yes. So basically, the resistivity. Just a second. The resistivity of alloys are more greater than the pure metals. Okay, Zainab?
Yes, sir.
So basically, the most common is the nichrome wire. Zainab, can you please tell me which material, which metal is used in the bulb filament?
I exactly don't remember, sir.
Tungsten.
Yes, sir. Tungsten.
Tungsten is used in the because it offers a very high resistivity. That's why it glows up.
Yes.
Here, yeah. So one more thing is the Electrical appliances use the heating element of electrical heating appliances such as electric iron and roaster are made up of alloys. Why? Why, Zainab? Why? Zainab? Zainab, are you there?
Sorry, sir, can you repeat it again?
I'm asking that why we use the alloys in the heating appliances, electrically heating appliances.
Because they produce heat while.
Yes, because the resistivity is high. Yes, resistivity is the term which is the key word in the answer. Whenever you write the answer, if somebody asks you why we use alloys rather than the pure metal, so you will say that we need, because the alloys offers high resistivity and they require high resistance value, because they are very high resistance value. Now that's why they glow up. Because yes or no, that's why they glow up now. You have seen
Yes.
that like roaster, the wires of the roasters are inside, they don't show. But when you see the iron, when you open the iron back plate now, you will see that I've seen that the iron back plate becomes red. And the
Yes.
I've seen that electric heater in here, like winter is very good. So I've seen that thing because we have electric heater. So I've seen that it becomes very red, orange color almost. Okay, is used making the heating element. Because the nichrome has a very high resistivity. Sorry for my bad writing. Actually, my hands are like a little bit sweaty because of that pen is slippery right now.
It's okay, sir. So what is after F?
This
Yes, sir.
OF, electric heating element of electric appliances. Okay. Nichrome wire, because nichrome wire is like nichrome wire is used because it does not get, basically it does not go, it does not burn easily. Nichrome alloy.
Sir, I have heard that alloys are a mixture of.
Yes, yes. Alloy is a mixture of 2 to 3 metals.
Yes.
Yes. So basically, basically alloys are much more stronger than a pure metal. You have seen steel wire, like steel grills and all. You have steel utensils as well. So basically, they are the steel is also a alloy. It is also an alloy. Okay.
Yes, sir.
Yeah. Alloys are made. Sometimes we need alloy to basically increase the strength of the material. Clear, Zana? Let's take one question here. So basically, it would be better if you remember the value of copper, the resistivity of copper and the aluminum resistivity. Because only two things, 1.69 into 10 to the power minus 8 ohm meter. Another is 2.63 into 10 to the power minus 8 ohm meter. The minus 8 will be same for all the values. But a little bit change is the magnitude. The order is same. because it's of 10 to the power minus 8, because that's how we are able to identify which one is greater and which one is less. So let's do this question here. Okay, so it's saying that, yes, Anna?
So nichrome wire does not, nichrome alloy does not burn.
Does not burn easily even at high temperature. Clear? Now see that, now Zainab, see that we need to calculate the copper wire resistivity. A copper wire of 2 meter length is given and the area of cross section is given 1.7 into 10 to the power minus 6 meters square. You can see that the values are not one. What we have done, like what is the definition? When we take the, if we basically, if you are saying the specific resistance, it will not change if the length and the area of cross section changes. I've told you just above. Example. Yes or no, Zainab?
Yes, sir.
I've told you, no? It does not change.
Yes, sir.
So that's now this question will tell you, like, will prove this, that this does not this will not change. The length is 2 meter, area is 1.7 into 10 to the power minus 6 meter square, and R is given as 2 into 10 to the power minus 2. Clear? Ohm. Value of resistivity is R A by L. Clear? Put the values here. R is 2 into 10 to the power minus 2 into A is 1.7 into 10 to the power minus 6 divided by L is 2. Yes or no, Zainab? So 2 will cancel out this 2. Yes or no? What is left? 1.7 into 10 to the power minus 6 into 10 to the power minus 2. So bases are same. This will get added. So what will be the value? Minus 9, minus 6, minus 7, minus 8.
Minus 8.
Minus 8.
Minus 8.
Minus 8. Very good. Ohm meter. Now see that whether the cross section is the same or whether the cross section is 1 or not, it will not change. The resistivity of copper will not change if you change the dimensions. The resistivity will remain same. Clear, Zainab?
Yes, sir. So can I copy the question?
Yes, sure. Take your time. Let me just a moment. Zainab, done?
1 second, sir.
Okay.
Done, sir.
Okay, that's great. So that's what. Zainab, is that clear here? Any doubt till now?
No, sir.
Yeah, that's great. That's great. That's great. Okay, so yes, let's take one more question, because these kinds of question will be there. Let's this is the NCERT question.
Yes.
Okay. So two questions are there in the, like, this is a single question, but two parts are there. You live in Middle East here? In which country?
Wait, sir.
Wait, so like right now it's a little bit winter, or like normal weather?
It's going to turn winter, sir. Like now it's kind of a muddy type.
Okay, okay. Like not a, like it's a very good weather right there.
Yes, sir.
Okay, like around 20 to 22 degrees Celsius, which is a ideal temperature.
No, sir. 32 like that.
32, it's still hot.
Normal
It's
is 52, 53 like that.
52 and 53. Oh, man. It's a very high temperature, like will not bear it. Definitely not. Okay,
Yes, sir.
let's like find out. Now we need that the copper is, the dimension is given of the copper wire, which is D is equals to 0.5 mm. So if this is 0.5 mm, if I can write 0.5 into 10 to the power minus 3 meter. Yes or no, Zainab?
Yes, sir.
So this decimal can be written as like this, 5 by 10 into 10 to the power minus 3.
Yes, sir.
So Zainab, if I take this into 10 to the power, like this denominator 10 into the numerator, it will become 5 into 10 to the power minus 4 meter. Is that clear to you or not, Zainab? You got it?
How did
Okay.
it become minus 4?
Zainab, this is in positive, 10 to the power 1 is in positive in the denominator. If you take that denominator into the numerator, it will become 10 to the power minus 1.
Yes, sir.
Let me explain this to you here. Equals to 5 into 10 to the power minus 3 into 10 to the power minus 1. Yes or no, Zainab? And the
Yes,
bases
sir.
are same. The values get added. Minus 4, sorry. Into 10 into 5 into 10 to the power minus 4 meter. Clear?
Yes, sir.
Very good. Now resistivity is given as
So resistive.
it's resistivity here.
Yes, sir.
1.6 into 10 to the power minus 8 ohm meter. And the resistance is given as 10 ohm. Clear? We need the value of length. Length is not given. So let's come to the formula. R is RA by L. So if I basically interchange, L will be here and rho will be in the denominator.
Yes, sir.
RA by rho. Put the values here. One more thing, we just forgot to calculate the area. Area is pi R square. Yes or no?
Yes, sir.
Zainab, if this is, suppose that this is D na, so R will be, just a second. R will be equals to D by 2. Yes or no? And D by 2 is 5 into 10 to the power minus 4 divided by 2. Yes or no?
Yes, sir.
And it will be 2 5s are 2.5 into 10 to the power minus 4. And R will be equals to 25 by 10 into 10 to the power minus 4. Again, this 10 will go in the denominator. So it is 25 divided into 10 to the power minus 5 meter. Clear, Zainab?
Yes, sir.
Very good. Let's calculate the area first. Area is pi R square, which is pi into 22 by 7 into R square is 25 into 10 to the power minus 5 into 25 into 10 to the power minus 5. Clear? Put the
So I
values
can
here.
say
Yes.
3.14.
Yes, Zainab?
3.14.
Yes, you can. It's not like it's up to you. Like if you use 3.14 and you can use it if you want 222 by 7, you can use that as thing as well. Clear?
Yes, sir.
Yeah. R is 10 into A is 22, like 25 into 25. 22 into 25 into 25. How many tens will be? It is 5 and 5, it will be minus 10.
Yes, sir.
Divided by 7 into resistivity. Resistivity is this 1.6 into 10 to the power minus 8. Okay, Zainab?
Yes,
L
sir.
is equals to, so Zainab, 10 into 22 into 25 into 25 into 10 to the power minus 10. If I take this, basically, or one more thing we can use, do is that 16 into 10 to the power minus 9. Can I do this? If I remove this decimal,
Yes, sir.
this will become in the denominator and this denominator will go add up here. If I take this in the numerator, because
Yes,
negative
sir.
power, and if I take this negative power into here numerator, it will become positive.
Yes, sir.
22 into 25 into 25 into 10 to the power minus 10 into 10 to the power 9 divided by 7 into 16. Clear, Zainab?
Yes, sir.
L is equals to, so Zainab, 16. 2 8s are 16, 2 5s are 10. Clear?
Yes, sir.
Very good. One more thing is that this would be 3.1. Clear? And this would be 3.125, because if you divide 25 by 8, it will be 3.125. So you have left is 5 into 3.1 into
Sir, it
3
is
point,
minus 9 or minus 10? I mean, minus 9 or just 9?
it's just 9. Clear? Into 25 into 10 to the power minus 1, because minus 10, so minus 1 will be left. Clear?
Yes, sir.
Yes or no? And one more 25 is also there. This 25 is left. Okay.
Yes,
So
sir.
this calculation will be equals to 122.7 meter. The value of length, you can add, multiply it. Right now we don't have time, so that's why I'm not able to calculate this. Is that clear?
Yes, sir.
Okay. So Zainab, second part will be your, you can say it's a kind of homework. Like I will be sharing homework questions separately, but this is a kind of which you have to try on your own. If the diameter is doubled, what will be the effect on the resistance? Not resistivity, resistance. So resistance change because of the change in area.
Yes, sir.
So you have to try it on your own, and then in the next class, if not, I will explain that to you.
Yes, sir.
Clear?
Sir, can you show the final answer, please?
This one?
Yes, sir.
Okay, okay, take it.
Yes, sir. Done.
Yeah, okay. Clear then?
Can I take a screenshot of that?
Yes, yes, you can.
No, sir, the question.
Okay, correct question. Yes, yes, that's a good question. Take it.